Hi guys, my name is Ahmad and this is my YouTube channel where we will learn about SystemVerilog and UVM stuff. Today's topic is bit stream casting. It is used to copy data from one data structure to another. As you can see from the name as well, it is bit stream casting. It means that we are copying or sending the bit stream, right? It is widely used in test benches. For instance, you have a lot of packets and you define structures to store your packets, right? And now you want to copy your packets to the queue or any other data type so you can further process it. So you can do this by using casting. You don't have to like write a loop to fetch data or to copy into another data type. You can simply do it by one line code or by doing casting. So we have few data types here. We have queue here, structure, memory, which we can build by using unpacked or packed arrays. We have integer as well. So we will try to send the data from these data types into another. We have to remember a few rules because if we don't, then the compiler will throw error. And the rule is that we have a source data type, we have a destination to which we are sending the data. They both should be of same size. For instance, if memory consists of 4 bytes, and we know that integer is also consists of 4 bytes, right? So we can send the data from memory to the integer. The same goes for structure and queue as well. But you know that queues are dynamic in nature, so you don't have to define size for them, right? Compiler will do that. For instance, if you have a structure and you have a control and data which consists of 8 bits each, and your whole structure is of 2 bytes, and you don't have to you just have to initialize your queue. You don't have to define your queue that it is of 8 bytes or 10 bytes. The compiler will do that. Okay, the compiler will automatically adjust the data size. So let's go to our coding section and try to learn this. This is our TB top. I have defined the structure and queue here. Queue is 8-bit wide and dynamic in nature. So we'll copy the data from the structure to this queue. We have a memory here, which is 8-bit wide and has 4 location. It means it can store 4 bytes, right? We have integer here, which also consists of 4 bytes. So it means that we can copy the data from this memory to this integer because they are of same size. Otherwise, compiler will throw the error. But in when you are copying the fixed data type to the dynamic data type, which is queue in this case, then for dynamic data type, you don't have to define the size, right? Compiler will automatically adjust the data. So, for instance, we have the 2 bytes of data. We have a structure of 2 bytes, right? So, compiler will automatically adjust the size of this queue to 2 bytes. So now, at first, we will copy the data from this memory to this integer. Okay, integer is our destination data type, memory is our source. So this is the syntax we have to follow, and our destination variable will be at the left side, and then there will be a destination data type, single quote, and in round brackets, we have to define the source variable or source memory, right, which we are copying. This is all we have to do. And now successfully done casting. Now let's run it and print it. The same data should be displayed in the integer as well. And you can see that number is same. Now let's talk about the position. So we created the bit stream of this memory and we copied it into this integer, right? So the position will remain the same after performing casting. It means that uh, the data at LSB side will remain at the LSB side. Okay, so you can see that in memory we have AA at LSB side, and in integer we have AA at LSB side. It means that the position will remain the same. So that's how you can perform bit stream casting. So now let's move towards structure and queue. Now we want to, you know, copy this data which is in this structure into this queue. Okay. So let's uncomment this code. We have to initialize the structure first, and we are initializing it by name, by giving the name control data, and we are setting the values, and we just have to give, uh, we have to follow the syntax. It means that the destination variable will be at the left side, which is queue, right? Because we are copying the data into the queue. Then we have to keep the destination data type, and destination data type is queue as well. We have defined it by using type def, right? Type def here, and then we have to give the source memory or source data structure. So this is all we have to do. And now the control and data will be stored at the queue location. And again, the locations will be the same. It means that control is at the LSB side, right? And data is at the MSB side. And in queue, they will remain, they will follow the same locations. It means that data will be at the back side of the queue and control will be at the top side of the queue. So let's print it and check it. So you can see that my queue is 10, 8. It means that 10 is at the, sorry, 8 is at the LSB side, right? And 10 is at the MSB side. So you can see from here as well. So that's all from my side on today's topic. I hope you learned something good today. Keep following my channel. See you in the next video.